Find a real symmetric matrix to the quadratic form x1 square plus 4x2 square plus x3 square minus 4x1 x2 plus x1 x3 minus 4x2 x3. The quadratic form containing 3 variables means we get 3 by 3 real symmetric matrix, 3 rows and 3 columns. Now, first row, first column, I am writing here x1, x1. First row, second column, I am writing here x1, x2. First row, third column, x1, x3. Second row, first column means we can write x2, x1 or x1, x2. This position of this one. Second row, second column, I am writing here x2, x2. Second row, third column x2, x3. In the same way, last element I am writing, I am once again explaining the position of last element. Third row, third column x3, x3. By using that logic, we can write here first row, first column means coefficient of x1 square 1. First row, second column, coefficient of x1, x2 is minus 4, half of that part minus 2. Position of next element, first row, third column, coefficient of x1, x3 is 1, means half of x1, x3 is 1 by 2. After completion of first row, you can write immediately first column because we are writing real symmetric matrix, means first row, first column elements are same. Means what are the first row elements? 1, minus 2, 1 by 2. Now in the same way, you can write first column elements 1, minus 2, 1 by 2. Now come to the next one. The position of next element is second row, second column element, that is coefficient of x2 square. Coefficient of x2 square is 4. Now this one, second row, third column element, second row, third column x2, x3 means coefficient of x2, x3 is minus 4, half of minus 4 is minus 2. I completed second row also. Immediately you write the second column elements. Means the second row, second column elements must be same. Second row elements minus 2, 4, minus 2. Then second column elements minus 2, 4, minus 2. Now the last column, anyhow, position of last element, coefficient of x3 square. The coefficient of x3 is 1. Now therefore real symmetric matrix is A equal to 1, minus 2, 1 by 2, minus 2, 4, minus 2, 1 by 2, minus 2, 1. Similarly, another problem, write a quadratic form to the symmetric matrix A equal to real symmetric matrix. They have given real symmetric matrix. Observe this one. First row 1, 2, 3. First column 1, 2, 3. Second row 2, minus 1, 1. Second column 2, minus 1, 1. Third row 3, 1, 4. Third column 3, 1, 4. This is real symmetric matrix. First row, first column. Second row, second column. Third row, third column elements are same. Same logic, xx, x square. First logic, according to first logic, in the first row you fix with x, 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 x. First element as x. Second row, y, y, y. I have to write here yx. I wrote here xy. You can understand. Y, y, y. In the third row you fix with z, 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 z. After that, in the first row you write x, y, z. In the second row again x, y, z. In the third row again you write x, y, z. Now coefficient of xx is x square. Coefficient of yy is y square. Coefficient of zz is z square. Now coefficient of here principal diagonal elements are 1, minus 1, 4. Means these are the coefficients of x square, y square and z square. X square minus y square plus 4z square. Now xy, xy means how this is xy, this is xy. If you are adding these two things, 2xy. In the same way, here also 2 is there, here also 2 is there. You add these two elements. How much are? 4xy. 4xy I wrote here. Again 3, 3. Now 3 plus 3 is 6. 6, here what is the position? What are the variables? XZ, here also XZ, therefore 3 plus 3 is 6XZ. The next one, already I wrote this element, and next this YZ. In place of YZ, we have the coefficients 1, 1, elements are 1, 1, 1 plus 1 is 2, 2YZ. The last ZZ is there, already I wrote here, the coefficient of Z square is 4, 4Z. Therefore, this is the quadratic form, x square minus y square plus 4Z square plus 4xy plus 6xz plus 2yz. Similarly, if they have given quadratic form, means we can calculate real symmetric matrix, otherwise from real symmetric matrix to we can construct quadratic form.